Hey Matt, and I thought I would do another video about 5.4. I decided to pick number 11 because it looked like a big one, and I thought that might be helpful. So we'll take a look at number 11 together. In this question, it says that there's a city with a population of 62,000 people, and they have 480 police investigations in a year. And then when the population rose to 74,000, the number of investigations was 640. So they're wondering if this trend continues, then how many investigations will they have when the population reaches 100,000? So, this is a pretty standard kind of city planning activity that cities do actually have to do. If the city's growing, they have to plan budgets and things for, how many police they'll have and how they're going to allocate those budgets and that kind of stuff. So it's probably actual kind of math that you might do. So let's take a look and see how much crime we expect it to be when the population reaches 100,000. So first of all, we need some kind of equation that's based on this information, and then we can plug in 100,000. First thing to wonder is, which is our x? Is it investigations or is it our population? So I'm going to say that for sure it's got to be population. Just because you increase the number of investigations doesn't mean your population is going to change, right? But as the population changes, naturally over time, you're going to get more investigations. Like a small town doesn't have that much crime, but you can imagine a big city's got like lots of crime. So that's what's going on. So definitely the X's have to be the population. So let's take a look. I'm going to slide this over here. We'll look at we'll try and draw this this out over here. So I'm going to start with finding the slope. So slope is equal to the change in the y's, the difference of the y's over the difference of the x's. So for us, that means we're going to have on top, the population is going to be y, so it'll be 74 minus 62. Oh, wait. No, I said that wrong. The investigations is going to be the y. Yeah, we just talked about that. So we'll do 640, sorry, minus 480. Sorry, I'm running out of room. Oh, I don't know what to say about that. I just got my notifications coming on. Spectacular. Wait, oh, that didn't work so well. Try again. You can do it, Mr. Pelche. I can hear you calling out. Your support is appreciated. 640 minus 480. I don't know how I'm going to fit in these big numbers on the bottom. I'll just have to use the K again. So it's going to be 74K minus 62. I'll put in those numbers later. I'll come down here. Hopefully this is making sense. So I'm going to do 64 minus 480, which I think is 160. And 74 minus 62,000 should give me 12,000, I guess. Yeah. So I'll put the zeros back in now that I have some room. So there's my slope. It's not so good. I can simplify. And actually, because I've recorded this video like 4,000 times, because I keep screwing up. But this is a long story. Anyways, I just calculated it, and it turns out to be 1 over 75. So what does this say? Basically, it's saying for every one person every 75 people we add to the city, we could expect there be another yearly police investigation. So that's what the slope's all about. Okay, so now we got to go do it. We're not done. We're supposed to find out this information. The slope's important, but I don't really want to count increments of 75 from like this to 100,000. I mean, I guess we could. You could take that difference, divide it by 75, and that would tell you how many more increases there will be. That would possibly work. So I would think that would be pretty reasonable. I'm actually kind of curious. Is that a valid solution? I think it's pretty good. So we could say, well, there's 74 right now. 74,000 could be 100,000. The difference in that population is going to be 26,000 people. So if I divide that by 75, yeah, it doesn't work out to a very nice number. So maybe I won't go with that plan. But it's about 346. Maybe round that up. So then that would be an increase from 640, and that would give us 987, which does turn out to be the right answer. So if you just kind of were to calculate, well, if I'm going up by 1 every 75 people and just like figure out how many people that is, that would be a perfectly fine way to answer it. We could also just come up with an equation. So that would be another way to solve it. Let's do that. I would say, maybe I'll use my point slope form to say, y minus, and then I would choose my y. So that would be, which point should I choose? Maybe I'll choose the smaller one, 480 equals the slope, 1 over 75 times x, just don't have enough room, x minus, and this is the big one, this is the population one, so it'll be 62,000. I kind of ran out of space, so I'll fill that out in a bit. I'll put a k here just to make sure we know it's a big number. Okay, so I'll keep on going. So this side hasn't changed much, but I'll multiply through by 1 over 75. Actually, maybe I should just multiply both sides by 75. That would make sense. Let's cancel this guy out. So I'm going to say this is going to become 75y minus, and then 480 times 75 will be 36,000, and that will equal x 36,000. Sorry, x minus 62,000. Can't fit that in, so just write x like that. And then let's see. I guess I could bring over my 36,000. So this would be 75y. I'll just add 36,000 to both sides. So that will become, I guess that would be x minus 26,000. And then I think I guess I'll just divide. I guess I end up just dividing by 75 anyways. So I'm not sure if that was such a great path. I mean, I guess I'm happy now. I could plug in the population and then solve for it. That would be fine at this point. Population, remember, is going to be x. So that would work out okay. So I could just plug in 100,000 for x. So 75y equals 100,000 minus 26,000. We can't fit it in. That's okay. So that works out to be 74 equals 75y. And then to solve for y, just divide 74,000 by 75. And I get the same number. 986.6 ... We'll call it 987. So sort of two ways to solve that problem. And you can always feel free to solve the problem in either using sort of your critical thinking problem solving skills or by coming up with an equation. Either one sort of tells you the same information. They aren't more clever than the other. They're both saying the same thing. You're just understanding them differently. So there's question 11. What a beast of a question. But that's how we got the answer. And I really wish my pen worked. is the end of my sad story. I'll keep working on that pen. It's pretty messy. Anyways, I hope that helped. And I wish you the best of luck on these questions. Bye.